In this video, we are going to go over some weighted atomic mass average problems. Basically, they're pretty easy. I'm just going to show you how this worksheet is going to work and what to do in case you have questions. So, number one, it says the weighted atomic mass of an element is based on what? You just look it up. It's out of your notes. You should know it at this point. Basically, it's define what weighted atomic mass is. Number two, it's not really a question. What number two says is as you go through problems 3 onward, I want you to highlight the term they use to refer to the weighted atomic mass average. And the reason I'm doing that is because they do not refer to it the same way every time. And so a common mistake I see a lot is that they'll know the concept, but then the question will use a different term. Instead of weighted atomic mass average, they might call it the, like for example, in this next one, they refer to it as the average isotopic mass, because when you have elements that have the same element but they have different masses, they're called isotopes. So average isotopic mass is the same thing as the weighted atomic mass average. And so I want you to get used to seeing all the different ways they will refer to these problems or this concept, so that way you won't get thrown off by just by changing the name of the topic when you're not really changing anything else. So I'm going to do 1 or 2 problems with you. I may just set them. I'm actually just going to set them up for you at this point. If you need to see how these are done, then go to my previous video in the notes, and I went over how to do these types of problems. So for number 3, we'll just set it up real quick. 75% of it weighs 35, and 25% of the isotope weighs 37. So 75 times 35, and then 25 times 37. Add it all up, divide by 100, and get your answer, and the units is U. So by looking at this, I can actually predict the answer, because I know 75% of it weighs 35, and only 25%, which is far less, weighs 37. So the average is going to be closer to 35 than it is to 37. And so when I get my answer, I should get something that's like 35 point something. All right. So that's that's a good way of predicting your answer. You'll know if you did it wrong or not. So let's look at number 4. Number 4 says a sample of element X contains 90% of 35X. So if we go to number 4, we have 90% of it weighs 35. I don't need to know the element. I just need to know the mass of the element, and the mass is in the top left-hand corner of the symbol. And then 8% of it is 37. 2% of it is 38. So then I add them all up, divide by 100, and I'm going to get an answer that's very close to 35, because 90%, which is the bulk of it, weighs 35. And so your answer should also be 35 point something. The numbers being the same as the previous problem are just a coincidence. All right, so that's how you do this. And just to do one more, hopefully I'll see it, is on number 5, if you look at the term they use to refer to this, in number 5 they call it the average atomic mass. So here they're calling it the average atomic, here they call it the average isotopic, here they call it the weighted atomic mass average. So as you can see, these terms tend to change even though they really mean the same thing. There is a back to this. Make sure when you turn this in, you show all work for the math.